gonna blow. Just wanted to give an update on what's going on with, oh, why did that shouldn't have stopped. So I've been working on trying to get my LoRa unit working and doing some, I guess, well, I want to do send and receive, and also wanted to, as the picture shows, have some LED lights working. So I soldered up a new board, or a new, I don't know what you call that, perf board?
Yeah.
And I wanted to have, like, figure out all my wires and have all the connections in one location. So just sync the LoRa unit there, and then have all of the wires that I need or connections already sort of pre-soldered. I don't, at some point it might be interesting to get a PCB made, but that's what it looks like at the moment, is running multiple lines to that one line across the back. I printed off a little label there to try to keep it straight. What that looks like is I wrote down my requirements. I think I've mentioned these before, but like, needed to have throttle and steering, needed to have a dead man push button, needed to have a mode switch, needed to have an e-stop switch. Decided I would program a push button to reset the lower unit if I needed, and the status LED. I was thinking I was going to have multiple status LEDs, but then I figured out I can get multiple colors off of one pin, and then something around the power, and then something around monitoring the power. So those are the steps, and I needed, this was just a little sheet that the bottom reference is a little bit different than the top reference, or it's actually reversed. So I was using this to sort of keep track of the coordinates on the perf board, and keep track of the color of the wire, and keep track of the location of that particular pin. So anyway, it was just a way to, because I'm old and get confused easy. So it was just a way to keep track of all that stuff. And so what that looks like at the moment is, I know that this is small, so these are the pins on the, over here, these are the pins on the lower board, and these are the ones that I've used so far, most of which are on this side, but I still have some space on that side. And then on this side, I've still got a few pins that are available. These, like this drives the OLED, so I can't use that. And these drive the LoRa, so I can't use those. So there's still, a number of pins available to make use of. So this was just my attempt at keeping track of that. And at the moment, let's see. I was going to.
That's an addressable LED strip you got on there?
It is, and I was going to show you some of the code. Let's see, where did I put that? Well, I guess I'll just open up the Arduino. What did I do with that? I was going to show that to you, and I told myself I was going to save that someplace, but let's just fire up the Arduino. But yeah, so figuring that out, and I'm still a little bit, this is meant to be pseudocode on what I was going to do on the, oopsie daisy. So, I mean, to do the, it happens to be a NeoPixel. I think it's a NeoPixel, but it works with NeoPixel driver, which is the Adafruit sort of branding of addressable LEDs. It's quite simple. You just sort of say, how many LEDs do I have? You got to load this library, but they've got some preset colors, or you can be more sophisticated and muck with the colors. But I was just trying to get the basics nailed down. So that's what sort of the series of commands you need in order to get color showing up on one of those LEDs. And like it shows, each one becomes addressable. And so with one pin, if you don't mind the spacing that you get with the physical, the way it's physically laid out, you know, each one of those becomes an addressable LED, which is pretty cool. So the notion is one would be, hey, is the lower signal there, or and good, is the battery voltage good, and I forget what I was thinking about for the other LEDs, but I just started off with 4. The other thing that I had connected here is I don't really need it, but I thought it would pressure and humidity and temperature. It was more to help test the whole board and the communications. But some of the other Adafruit, getting the send and receive working has been a challenge, but I'm getting there. So this is that radio head. I'm going to call it routine or library. I was struggling with getting sensor data back and forth on the LoRa, and I'm not a good, you know, I'm sure might be a more C-like way to do that, but where I think I'm going is to define a data structure so that I can then transmit that data structure, because at the moment this code needs to be changed and is not working fully yet, but this, where's the send statement? Yeah, this is what the sending, I need to test that, but that's the example I could find because the send wanted that as opposed to some other data type. So I was struggling with data types and getting a lot of errors around not having good data types because most of the examples were just this straight, and that worked fine. But then when I tried to apply, an integer sensor into that, it didn't like that at all. So I had to go with that and using the data structure, which will work. But that's my next. So I figured out the LED. I figured out, I think, using this this library, I had a basic sending and receiving just using constant text. And so now the next step is to implement this data structure to try to get that to work. So, and then as I was saying, I was trying to figure out sort of the pseudocode around what was I going to have on the remote and what was I going to have on the tractor. So that's where I'm at, I think. That's where I'm at on that. Still mucking around with the LoRa and the board and the software to send and receive the remote control data. I think that's all I've got.
Yeah, I went through that thing with the, you're talking about data types and the fact that one's an array of bytes. And let me see if I can pull this code up here. I said I was going to put this out somewhere where people would get to it, and I didn't get around to doing that. So let's see, this is going to, okay, it's got that far. Let me see this. Can I do that? Okay, so let me try sharing this. And one of these has a lot of extra crap in it that's all commented out, but here's the same. This is probably the same code you start. I'll start at the top here. This is probably the same code you started with here.
It is.
And it doesn't, I didn't put any website or anything, but it looks like the same kind of stuff. So again, yeah, you include libraries. Why do I have SPI in here? This I think is on the transmit. This should be on the oh, I know why it's got SPI, because it's talking to the radio. That's why that's in there. And here's that thing you're talking about last time about how do you know which board it is. And it says for feather M0, that's the one I'm using. And then down here it says if, it says if you have the, I think I just commented all this junk out because as you say, how do you know, like right here it says if defined that, and it went all the way through and didn't find anything. So it just basically up here, it just simply says, I defined those values and they work. So it'd be better if I put this down at the bottom, this whole block, put it down after it's doing all the checks, and that way it'll fall through. And if it did anything to it, this will override them anyway. So that was something you're asking about last time. Let's see, I said the frequency, blah blah blah. Here's LED. So I just define some variables here for reading the joysticks, and this B1 is simply that's the bits, I think is what that was. So down below, I'll show you where I just read a single pin and then merge those into to create this value. So I've got 4 integer values for my 4 joystick axes, and then 1 integer for a combination of all the bits stuck together. So we come down here, it's just initialized all the pins, and I turned on pull-ups on everything. Let's go down to the loop here. This is just all the setup stuff. So we come down, and there's a lot of extra debug junk in here where it's spits out. If I plug it into the computer while it's running, I can see that stuff. But normally in the box, it's not doing that. So, okay, here's the loop right here. And it says wait 1 second between transmits, but it says delay 10. So it's probably 10 milliseconds. This is where I kept trying to speed the thing up.
Right.
And just the overall sending and receiving takes long enough. It got to the point where it wasn't going to send it any faster than what it wanted to anyway. So basically right here, it says read the input pin. So I just say do a digital read of IO pin 0 and put it into value. And then I just simply wrote that into the B1 integer. And then down here, I'm going to start merging in more. So it just simply says debug print. So it simply reads a bit and it loads the entire B1 with so it's going to load either a 0 or 1 into that B1. The next one says go out and read up another pin. And here I take B1 and just shift it over by 1 place and then merge the new value into it. So I'm basically taking the bits and just building up that integer by sticking the bits into it. So this way I'm able to read a single pin at a time, and then it converts it into an actual integer and see. So I go through and read all the pins this way, so I can grab them any. See, it said read pin 0, read pin 1, and then down there it says read pin 12, and then read pin 11. So I can pull up in any order I want and merge them all together. So I just went through and did all that, and digital read. Okay, there's commented on stuff. And then to get the joysticks, I just simply read up to the analog read my joystick. And depending, somewhere it says for 10-bit joysticks. And if you don't do anything special, it's going to read the input as a 10-bit input coming in. But you can go in on, at least on the ARM processors, you can go in and say something like analog resolution 12. So you can actually get more resolution on that if you want to. But I ended up just keeping everything down to a single 8-bit number. And that way I could just take a byte, that's the value. So it's plus and minus 128. And just, I was transmitting that. Because if I go any more than that, then I have to go to 2 bytes for everything. And I didn't do that. And down below, I say, I'm going to say something about for 12-bit joysticks. But anyway, I just take the value I read in, and this is my center point. So I just subtracted the value from the center point just to give me, if you're not touching the joystick, it'll put out 0 or close to 0 by doing that. So you see this center point. Oh, what else I got? 1, 2. So one of them is 517 is the center, and one of them is 525 is the center. One of them is 516, and one of them is 514. So they're not all right. They're not all right at 0, but that I just went through with it sitting there and reading up the values and said, okay, what's not touching at all, that's the center point of each one. And I just wrote those down and then stuck them in the code here. So let's see, if joy is greater than 127. So I'm just clipping it to plus and minus, basically plus and minus 128 here, just so it doesn't overflow my 8-bit number. And then I just said so joy 1 and joy 2 and joy 1, 2, 3, and 4. I'm just reading up the values. And then right here, I see right here, I was putting in comments that with it just sitting there doing nothing, the center position is 525 and then full up and full down. I just wrote the values down so I could, figure out what I was doing there. And then I'm just printing out the values on the screen. Sequence. I don't know. Oh, sequence is I just had a number. Each time through the loop, I'd increment the sequence. And that's another thing you can do. If you're losing packets, you can check for that at the end and say, oh, gee, that should have been an increment, the next incremental number. And if it's not, that's another thing you can do for error checking. I don't think I'm doing anything with it other. I probably am sending that across right now. So when I get ready to transmit, I turn the LED on. And then when it comes back, it turns the LED off. So basically, I just get a flickering of the LED as the thing runs. So what else has happened? So here's that sequence. I'm just incrementing that number just for something to do. And Why is this still in here? Is this commented out? No, it shouldn't be commented out.
Yeah, but you're defining radio packet with character.
Oh, I guess all this crap out here is just commented out. So yeah, it's just defining a 20 byte array to put the data in. So then down here, I'm just going to load up each section of that. So the sequence is that incrementing number. Then I just load up my 4 joysticks into those values. And the B1 is the one that's all the bits combined together. And apparently I was sending eight bytes. So my last two I just set to 0. So yeah, right here, that defines the array for the packet I'm going to send. And here I'm just stuffing values into it. And then it says, okay, if I got 12-bit joystick, then I'm doing some extra stuff here to, instead of, let's see, what was I doing here? Shifting that over. Now,
So
anyway,
then you're doing
I just chose to go with 8 bits instead of the 12 bits. And that way just, so this is commented out. I'm not using that right now. What's this doing? That's commented out, doesn't matter. So here's just picking up the time. What's it going to do? Serial print S delay 1. So this I think is putting this out, delay 1. Well, but again, I guess it's commented out, so we don't care what it's doing. And then right here, it just takes that packet and says we're going to send 8 bytes. It's going to point to the array here and say send 8 bytes worth and send that. And then it says delay, apparently delay, I assume it's delay 1 millisecond. And then it says wait for the packet. So as soon as you send it, it has some delay before it starts checking. And then says check to see has it been sent. And once it's sent, then it says wait for reply. So it's just simply defining the buffer to receive the stuff on and the length of that buffer. And then here it's going through that thing. It just says wait 5. I assume it's 500 milliseconds. So it says if you don't receive a packet in 500 milliseconds, then it falls down here and says it's just a receive error. And apparently I don't do anything with that. No reply. No last. Well, I'd have to look at this a little harder to see what I was doing here. So it's got lost my place. Serial print. Okay, so right here it says wait for that. So we come down here in this column. If it didn't get anything back, it's gonna just print on the screen. It says no reply, and the now minus last. It's just a keeping track of the amount of time it took, the number of milliseconds to respond on that. So if it does receive a packet, and when I went back and looked at this, I'm not actually doing anything. I just make sure the packet comes back, and then I could do something with it here to verify. So if it sends me something back and says, you know, here's my heading, here's my speed or whatever, I could extract that out of this packet then and do something with it. And right now, I guess I'm not doing anything with it, but it is sending data back and forth. And basically that's the end of it. So, and then when it's all done, then it turns the LED back off. So that's what makes my LED blink as it sends packets. And if it's not doing anything, if it's timing out, then it'll be a very slow blink, like, you know, once a second or once every 2 seconds, the thing will flicker. And if it's actually running, then you can see it flickering, you know, like somewhere between 2 to 5 times a second, you can see it's flickering. And that way, just by looking at the LED, that's just what they call the LED on the board, you know, LED 13. And I simply put an LED in parallel with that and stuck it on my panel so I could see that from the outside world. But anyway, the trick was that thing here with so basically this is if so you can go back and look at this later, or I could here, let me just cut and paste that. Yeah, I'll just do that much of it.
Yeah, you'll probably get a chat too big error.
Yeah, I guess if it's sticking in Slack, that would well, I'll do that later. But anyway, the point is, this is how you read the single bits. Read a single bit and shove it into an integer that's going to combine everything together. So the first time you just read it, it's going to be a 1 or a 0. And then the next time you say, take that number, shift it over one place to the left, and then add in the new value. So it's just going to build up as many bits as you want. That's what's going to be in that integer by the time you're done. And then the joystick, you just simply read up. You read the value with the analog read, and then take care of the reason why some of these say a number minus the read, or the other ones say the number we read minus the value. It's because to make it positive or negative, I think is why I was doing that. Why it works one way or the other. I suppose I could say, well, it's just something you play around with. You read it, and if the values aren't coming out right, then you swap it to change the sign or whatever. So anyway, that's basically the you were talking about trying to get your types to match. That's essentially what I've done here is created the array of I created, I think, a character array. Let's put them in the top
And
here.
put them into each individual character.
Yeah, so I stuffed each character of the array then with like down here where it said right there. So it says define the packet of 20 bytes, and then I just go down the line. I stuff the first eight characters of that with whatever I want in there. And so each one of those is an 8-bit value gets shoved into the character. The character being a assigned 8-bit value. So that's how I build it up, and you can stuff anything in there you want. And if we wanted more than 8 bytes, you could just make stuff more bytes, and then when down here where it says send and says serial print, right here where it says send, it says point to the packet. Now here I had to override, I had to typecast that so it knew, because it wants unsigned characters, and I was using signed characters. So this typecast simply says, oh no, trust me, those are really unsigned values. And then you point to the packet itself and then say send 8 bytes. So if you wanted to send 10 bytes or 12 bytes, you just make this number bigger. And that's just how many bytes of that packet it's going to send. And you probably have all that working at this point. If you're still sending a text message, maybe maybe that wasn't obvious, but anyway, that's the pieces I went through to make that work.
Yeah, you've found a path, and I'm still trying to make sure mine is going to work. I haven't confirmed that data structure thing is going to work yet. I got that from somebody, I've forgotten who, but yeah, all that shifting stuff, it hurts my head.
Well, it does the same thing again and again and again, so you just have to do it. Just look at it once, and that thing with the where you say B1, it says shift at one place to the left is what that is doing. So the 1 is how many places you want to shift, and the B1 is the variable you're shifting. So that's just one way to do that.
Yeah, but if I wanted, instead of, so the lowest value you could transmit this way, and the highest value is 126.
The actual physical value.
Yeah,
it's an 8-bit number, so it goes 0 to 255.
But if you wanted to go to 1024 or 49, then you'd have to do 2 bits, right?
You'd have to do 2 bytes, yes.
2 bytes.
So you have to stuff the low one into 1 byte, and stuff the high part of it into the second byte, or the other way, whichever order you want those in.
And then put it back together on the other side.
Yeah, on the other side, then you put them back together. And you could probably either typecast that or make I don't remember how you do that, but there's a clever way to, or make a union or something.
Yeah.
And yeah, I just do it brute force.
All that real programming, I've forgotten how to do all that stuff. Cool. Thank you for walking through that. That's and I was gonna, if you scroll down where you commented out the RSSI.
Yeah, I commented out a lot of that stuff once I got it running. I just turned all that stuff off, and it might be good to know.
When you get something back, let's see, scroll down a little bit more. Where you mentioned it might be interesting to get heading back or something like that. Yeah, right there where you've got that last RSSI. Is that, so if you've got, you send something and is this function giving you back the strength of the signal on the return or on the send? Do you happen to know?
I don't know. It said, I assume it's the send because it just says RF95.last RSSI. I assume that's the transmit side of it. So if you wanted
So
to get it, if you want to get it back from the receive side, you'd have to read it up there and stuff it into your bytes and send it across, and then you could strip the data off and do something with it. So in your case, since you got that little display right on there, you could put your RSSI right on your display, which I think you were already doing that. So yeah, that'd be a handy thing.
because I was going to use that to basically say, well, it was going to light one of the LEDs, you know, to say is a strong, medium, or weak signal.
Yeah.
But then I was also, if it doesn't get anything back, this, scroll down a little bit if you don't mind. If you don't get anything back, you're going to fall into that receive failed logic, right?
Yes.
Or no reply.
I think the failed is it does some kind of a check here. If that it's checking the apparently the size of it should reply.
Remember, I want to do a heartbeat sort of thing. Are we connected and is everything working?
Yes. So one of these two here, I think because you can do various things. Once you send the packet across, since I know I'm always sending 8 bytes, then at the receive end, you can say, I just received a packet. Number one, is it 8 bytes long? You might want to put, you could put, say, the first character is a certain thing that you know what it is. So there's lots of extra checks you can do to verify that what you sent across is what you actually want. And then you can expand it out. Of my 8 bytes there, I've stuffed the last 2 bytes with zeros. I could do a checksum or a CRC and shove that into those bytes. And then when I send it across at the other end, you can verify that the checksum or CRC is correct when it gets there. So there's a lot of extra error checking you can add on top of this to verify that what you're sending is actually correct.
Yeah, so I'm just making a note on my tractor code. I'm basically saying, am I getting a packet within the time frame I'm expecting it, right?
Yeah, because you have to put a timeout there. So if you're not receiving anything, you want the thing to, come to an orderly stop. And I think on my receive side, number one, I read up I've got 2 bits from my e-stop. It's got 2 physical switches on there, or maybe it's got 1 switch with the 2 positions, but I read both of those bits and stick them into my data and send it across. So when the switch is up, one is going to be high and one is going to be low, and with the switch is down, then the opposite will be the case. So I send both bits across, and that way if a wire falls off or something, you're looking at both of the bits on there. So on the receive side, you say, read up those 2 bits and they have to be the correct, maybe it's got to be a 1 and a 0, and any other condition is not correct. So when your e-stop is correct, you've got the 2 bits there, and it just simply reads those out and says, are those correct? And then that controls based on that check, I control my e-stop relay, which is coming off my microcontroller board. And then other things like, say, if you get a timeout, then I don't know if you want to declare that as an e-stop condition, or you could. At that point, you can just say, we didn't get data, at a reasonable rate. So you can either click your restop relay, or you can just have that as a status saying that you want to go into a pause condition. So it just more things there. You just have to decide how you want yours to work. And if your e-stop is actually set up to kill your engine, you may not want to have it. So if you don't receive a packet within a certain amount of time, you may want to just simply set your transmission back to 0 speed and not kill the engine. Whereas the e-stop when you hit the e-stop on the remote, you might want it to actually kill your engine. So Again, you just have to decide which way you want that to work.
Yeah, so I was just making a note on let's see, what screen am I sharing? You're seeing my notes?
Yeah, I'm seeing some kind of notes.
Yeah, so I just, on the tractor side, and basically, am I getting a packet within the timeout frame? If not, pause the tractor. And the other thing you mentioned that I think would be clever is to send back the heading and speed to display on the remote control. Might be interesting to get that back.
Yeah, you can play with that. Basically, any data you want, you should be able to send, either direction. And I don't know if making the packet longer slows down the transmission. I didn't really play with that to find out. I didn't say make one 8 bytes long and one 24 bytes long and see if that actually affects the turnaround time, or if it's more of the radio type stuff that's what seems to be slowing everything down.
Yeah, so I let's see if I have this might still be LoRa instead of, it had if available, but you had you had wait timeout. Go back to that. Where is the native fruit stuff? Too many notes.
And I don't remember if the original code had that wait available timeout command, or if that's something I looked up because I knew I wanted a timeout on that. So it could be I looked that up and added that in. But that command is documented under that library. So it's not something that I specifically did. It's just one of their commands that they have. So I don't remember if the original Adafruit tutorial or documentation used that or not.
Oh,
Probably any one of those boards is going to have
the same library.
Yeah, so right there it said technical details. It's usually where they put the go down. Usually if you click on that link, it'll take you to the stuff where they're showing you the code. And then over on the left, they're on those sections where it says probably under using the radio will be the Arduino type stuff. Some of their stuff's in Circuit Python, and then some of it's in the Arduino. So you just got to figure out which code they're using.
Yeah, here we are. So on the transmitting side, what does their loop look like? Yeah, they had the if available timeout or wait available timeout.
Yeah, so apparently I just copied that right off what they had there, and that seemed to work for what I was doing.
And one more time, that's the function of that is, it's not have I received something. It's,
Well, I believe it says, have I received a packet or not? So if you've received a packet, it falls through and you can decode it. if you don't receive a packet for 1,000 milliseconds, it falls through. I see they've got the two things down there. They've got one that says receive failed, and they've got another one that says apparently that bottom was a timeout. So the one that says receive failed, it's apparently checking for receive buffer length. Should be a reply for us now. If receive, so somehow that thing says if receive buff and length, it's apparently checking for the size there. And if it doesn't work, then it says receive failed. It just says apparently either there was no data in there or didn't like the length of it or something.
Yeah, and this is if this timeout is triggered.
Yeah, so the bottom one is the timeout triggers saying for some reason it didn't get anything. And that basically accounts for everything. If your batteries are dead, if you're out of range, if it's turned off or whatever, that, you know, you send a packet out and you don't get anything back, then it just simply says, we're not talking at all.
And this is if you got bad data or something about this.
Yeah, you'd
receive.
have to look that up to see what that's actually checking for. Because if it does that, it does the receive, and if it's true, then it goes ahead and processes the packet. If it's for some reason you do a receive and it says false, then it says receive failed. And I don't know what the difference is on that. And you may actually want to, you know, respond differently on this too, on your, since you're using it for remote control.
Yeah, and that's on the transmit side, and then on the receiver side, the loop looks like something's in my buffer. And I think we're suggesting this is if it looks like a good packet. And see, there's no timeout constraint on this one.
Well, that's because it's just simply listening all the time. So it's
Yeah.
just going to sit there and listen forever until something comes in. I think is why they've done it that way. So then also you don't, down at the bottom, you don't have two error conditions, because since you don't have a timeout, you don't have the error for the timeout.
This is a sort of what we would leave as bad data. This for some reason didn't work. Something's available, but it doesn't like it.
That's just my guess at this point without looking up to see what those are actually doing. So probably on the library, it's probably documented where it says, if available, they're going to tell you what that means, if it's received data or whatever. And the one that says if receive, and then it comes back true or false, then somewhere should tell you what that's actually trying to do there.
Yeah, that's helpful to walk through that. Thank you. Because if I'm I just need to put some sort of time reference in there. If the allowable time is still okay, then check that. Or maybe put that in here above that. Guess I could put it above either one of those. Well, do I have something available? Is it within the time frame? Have I exceeded the time frame? I don't know.
I'll pull up my code here and see what it says. See what I did with that. And on my receive side, it's a little harder to read, because I've also got the all CAN stuff put in there, since I was sending everything out the CAN bus then. So let me see, I get this, make this bigger, and let me see, So this is the one that's got a whole bunch of stuff here. That's all the stuff here is commented out. This is all sample stuff for the can. So I come down here, I should rip all that out. Okay, here it starts the actual, this should be the stuff that was copied from Adafruit for the receive side. So it's going to be go through the same setup stuff. Setting up the radio. Blinky on receipt. I normally wouldn't say blinky, but that might have come from the original example. So I've got an extra
from the original.
I've also got a red and a green LED that I stuck on my board. It's one of those combination red-green LEDs. So it basically follows my e-stop. If my e-stop relay is engaged, then the LED will be green. And if anything says we got a bad condition, disable the e-stop, and opens the relay, and the LED will be red, is what that's for there. So this is basically the red LED, the green LED, and then the relay pin to drive the relay. And then here's some stuff I was playing around with the CAN bus. Void setup, it just initializes everything. Probably initializes the radio, initializes the CAN bus. Yeah, CAN bus begin. And then set the initial state for the LEDs and the relay. So basically I'm using the what do you call it, the pin 13 LED, just simply called LED here. So that LED's on the board, and then I've got the red and the green. So I think the one on the board flashes again based on when it receives a packet, and the red and the green is simply the e-stop stuff. So my loop here, actually we are not receiving data. This right here, I think, is the section that's doing what you were just talking about.
Checking the time.
So it's reading up the built-in timer and checks to see how long it was. So this, I guess, is just simply reading the values up. We haven't done anything with it yet. If that is greater than millisecond timeout. Well, no, I guess my timeout millisecond is the time I've declared that says if we haven't received anything, then this I think it resets. Yeah, it resets the timestamp, and then what's it do? It turns off my e-stop relay. So it turns off the e-stop relay and turns the red LED on. So that's what I'm doing right there. Is that's doing what you're talking about right there. And hopefully this will be readable if you go back and watch it on the video. Otherwise, again, I'll make another attempt to put this out somewhere. And then it simply says, just like right out the SparkFun example, it just says, the loop says, we're always checking to see if there's data available. Should a message for us now. And then again, it does that check. And then I think again, based on the condition of what we received, either turn the e-stop relay on or off. Well, here's the other thing I was talking about. When I receive the data, I get this buffer back. So I go look at buffer position 5. That was my that was the all of the combined bits together, and I AND that with a 30, which is going to strip off 2 bits. It's going to strip off the 2 bits there, and of those 2 bits, they have to be this condition. So there you can either have a 00 or a 10 or a 20 or 30, and of those 4 combinations, it's got to be this, which says the e-stop relay or the e-stop switch is up. So one switch is on and one switch is off, and that's the 2 in that location is those 2 bits, and it's got to be in that condition. So if you pull it up, and if the e-stop is in the wrong condition, no, if the e-stop's in the right condition, then it turns the relay on and turns on the green LED, and if not, then it turns the relay off and turns on the red LED. So that's actually checking the e-stop there, and then somewhere the thing that was up above here, that's what's actually, where'd it go? This is the one in the loop that's actually checking to see if we haven't received a packet in the right amount of time. Again, that turns off the e-stop relay, it turns on the red LED, so you know there's a problem. So either hitting the e-stop switch on the remote, or if we don't receive a packet in the amount of time, it just turns off my e-stop relay. Now in my case, my e-stop relay just kills both of my drive motor and my servo motor. It's not like, say in your case where you got a gasoline engine running, you have to decide. See, in this case, you probably want the timeout. You could distinguish. So this timeout here could just simply say, send a 0 speed to your transmission, so the thing will just come to a stop and not move.
Right.
And then down below, if it's the detects the actual e-stop switch, this then could kill your engine. So you might want to distinguish between those two. And then otherwise, it's just simply it receives it. This is building up the CAN message here, all this stuff. It just says we're going to send 8 bytes on the CAN bus with an ID of 22. And then it transfers the stuff that came in, transfers to the CAN buffer, and then writes it out. So that was all CAN stuff. Then to send a reply, it just simply, I don't think I'm actually sending anything back here, but this is where you could put in, any value you want, just like in the Adafruit example, they just send a text message back. And let's see what's it actually doing here. Send size of data. So apparently I'm just sending back an R:. So that data is R:, and it sends the size of data. So it just sends, if I was watching this on the remote side on a computer, it would just show up on the screen and say R:, meaning I received the message. So yeah, you can put anything in there you want instead of just the R:. You can put, just like you did on the transmit side, if you wanted to get heading and speed and whatever, just take those and shove them into bytes and send it the way you did on the other side. So you just got, and then on the other side, you just have to decode that. So that's what that's doing. So that, yes, that accounts for the e-stop that's right in the bits. And this thing, the receiver itself actually interprets, it's looking for the e-stop condition by reading up the bits and controls that relay directly. And then also everything that came in from the remote, I put that into a message and send that out on my CAN bus. So which goes over to my main microcontroller. So it can also look at all that data coming back in, but the e-stop relay is, not going through any more than it absolutely has to. It's just simply when you receive the packet in, you look to see, do we have the correct condition in there? And if not, then we drop out the e-stop relay so the thing will come to a stop.
Before you close that start equals millis, what logic, can you just scroll up a little bit? That's within which if statement?
It's just right in loop, I think. Oh, it's each time you receive a packet.
Plain data.
Yeah, each time you receive the data, then it just resets the timer. So it takes whatever the current time is and puts it in the variable called start. And then this thing up here where it's under loop
Is calculating
where it
your
says millis minus start. So yeah, it says if that number gets too big, then we've had a timeout. So you put that reset in the it's in the point where you have received a packet, then it resets that.
Plain data.
Yeah, I assume it has to be a valid. Let's see what's it doing here. Yeah, so at this point we know we've received a valid packet. So that's where it's checking for the e-stop stuff and resets your timer. So it really doesn't take a whole lot to do that. I see now looking at it. So that makes sense.
Makes great sense. Thank you.
And as I said multiple times, it's best if you make your vehicle the master as opposed to the remote being the master. So basically, that way your remote is always sitting there looking for data coming in, and the data that would come in would be, back to the example, if you had heading and speed. So your remote's always sitting there waiting for something. It says, oh, I got a packet, decode your heading, your speed, and put it on your OLED, and then read up your joystick or your switches, and then send that back as the reply. So that way on the tractor end, it's running the loop where it says, once a second, it's going to say, send the heading and the speed to the remote, and whatever comes back, then that's all your joystick and stuff. So if you don't get that one back, so you got a condition where it says, I didn't receive the packet, either I got a bad packet or I didn't receive a packet in the correct amount of time, then that can, you can actually do something with that. You can do your e-stop condition and shut everything down if you're not receiving data, which the way I have it where my remote is the master. Well, I send the stuff out and never get anything back. Well, the only thing you do is watch my LED flickering on the thing to know if it's doing anything. I can't actually shut anything down because of that. So if I'd swap things, and it's actually fairly simple to do that. You just got to decide which one's the master and which one's the slave. And it just the loop that runs on each one has to, you just want the one on the tractor to be in control. And does that make sense?
It does.
Okay.
Yeah, getting that buffer thing in the character types, and you have well, I couldn't write that C code, but I found something that I'll give it a try.
And maybe what I'll do is I'll put this out on the Google Drive, like when I was putting out that whole directory of whatever I was trying to do. Maybe I'll just go out there and create a new directory and stick these 2 files out there.
That'd be cool.
Or if I can figure that gist thing, I might try that too. But it'd be available to everybody if we put it on the gist. And I think if you put it on the Google Drive, I think you have to be a member or something to access that. So I don't recall.
Yes, I think that's true.
And I really shouldn't just dump it out there the way it is. I should put some comments on it, but I probably won't. I'll just say that's just what I currently have. And
People are going to be appreciate just having anything to look at, just to check the thought process.
yeah, that's probably true.
Okay, we can turn recording off.
Well, my only comment is the only thing I've done, I went out to my garage. I've got a freezer in my garage. I went out to get some food and I looked at my lawn tractor and it's not as buried as I thought it was. So it, like 5 minutes of just taking stuff and throwing it somewhere else, opening my garage door. I could probably push it out in the driveway and get to it. So I may get the ambition to do that. It's pretty hot here today and I don't know. So that means the garage is going to be even hotter, but I don't think it'd take that long to push it out in the driveway and then I can get access to it.
Well, I'll have an extra day this weekend to putz around with it, so hopefully I'll make some progress.
Oh, that's right. We got a holiday coming up, don't we? Those always take me by surprise anymore.
I was supposed to anyway.
So, anything else, or should we stop?
I think we can stop.
Pause, stop.